In lecture 13, we are going to study optical equipment and measurement. In photochemical measurement and also spectroscopy, we need at first light sources, right? So let's think about the light sources. In general, we have three types of light sources, and the first one is lamp, which was invented at first as the light source. You could see the lamp, and the lamp has usually a whitish light. And you see, there's the key feature of the lamp is covering the wide wavelength range. And cheap, and usually used for illumination purpose. Illumination of the region to and also the other important point in photochemical process is UV light source. Even for now, UV light source is very difficult to obtain by LED or laser. And oppositely, laser light source is the monochrome. So as you see in a laser pointer, you could see that single wavelength. Mostly laser pointer, you see the red color or green color, right? So the monochromatic. So single wavelengths. And also the difference from lamp and laser, you see the laser propagate without diverging, right? So which is called a collimation. So just the laser can go straight. And this is related to the some of the properties of lasers. And the other thing is coherence, which could be studied later. That the only laser can be by inventing the laser, we can now use various interference measurements, and also the laser can be focused down to a very small spot, like 1 micron. That's why now we can use a laser scanning measurement. So each spot you can obtain the response or photochemical responses. In between the lamp sources and laser sources, you can think like the LED light source. Oh, the laser is very expensive. The price of LED is now probably in the middle, but actually LED is getting cheaper and cheaper because it can be mass produced. So this is made of the semiconductor. the device. So mass produced. And also, then the wavelength region is not like lamp source, but not like laser source. So the wavelength region of each LED is limited, but many varieties of the wavelength selection you could choose from LED now. So variety of wavelengths. Okay, so let's move on to the start from the lamp sources. First, you see the halogen lamp, which is most general the light source used for microscope or some general purpose of illumination, which covers the visible wavelength region. And you could see the lamp source itself looks like this. So the wire is connected to by applying a voltage, when the current is going to generate a light. And also you can see, as I mentioned, lamp sources are still used for UV light source, typical purpose of UV light illumination for photochemical reactions, for example. And the typical ones are mercury lamp, xenon lamp, or deuterium lamp, and they are used for UV light sources. And about lasers, you have several options of lasers. And the lasers are categorized depending on the medium for laser emission, and which are gas laser and solid laser and semiconductor lasers. And I just tabulated here for the properties of each type of lasers. And thinking about the stability, solid laser is very good. And gas laser is also good. But the semiconductor laser are also good, but it's getting better. But compared with these two laser sources, it's a little bit unstable. And about the coherence, I will come back here. It's you can now just think like coherence is the property of the light, which can be induced interference. And this is the solid laser is best one. Gas laser also good, but semiconductor laser is not so much good. About the price, as I mentioned in the LED part, so semiconductor laser is most inexpensive, so it's more available for anyone, and which is actually used for reading the DVD or some record medium. And the solid laser is most expensive, and gas laser is in the middle. So this is a general categorization of the lasers. Right? And first, in the gas laser, which was first invented as a laser source, and as you see, the helium, so helium and neon are used for the laser medium, which is called Hana laser, which has a wavelength of the red light source and 603 nanometer. And you could see like this. So here the helium and neon gas are included in the resonator, and due to the by applying the voltage, the gas start to generate the induced light, and then it is enhanced. So, and also argon is also used for as the laser gas laser, which has a like blue light. Blue light and 488 nanometer. But these days, this laser is mostly replaced by semiconductor lasers because of the stability issue. And a CO2 laser, which is originally 10.6 micron, so it's infrared. This laser is industry used for laser processing because you could increase the intensity very high. In the solid lasers, we have mainly two options still. One is neodymium YAG laser, yttrium holmium garnet. So what it is, it's the original wavelength is 1064 nanometer, so which is near infrared. And of course, original wavelength is somehow a little bit difficult to use because you cannot see. But so by wavelength conversion, and which is it's usually easy for to make the wavelength half, meaning the energy doubles. Is easy. So 532, and this is twice of the energy of 1064, and 3 times is 355, and 4 times is 266 nanometers. So you could obtain the visible UV and deep UV light we could obtain from neodymium YAG laser, and this is very stable laser. And also we often use titanium sapphire laser, which covers which is good for covering the wide wavelength region by tuning, optical tuning. So the tuning of wavelengths is possible. And also, this laser has been utilized for femtosecond lasers. As semiconductor lasers, we usually, it is made of the mixture of indium, gallium, and arsenal. And by changing the mixing ratio, you can tune the wavelength region. Typical wavelength is around the red region. And these days, there are really many varieties of the wavelength region. And then gallium nitride, which is maybe you heard it's around the 400 nanometer region, which is blue, right? Blue, right? And this laser is used for the Blu-ray, the reading of Blu-ray discs. That's why the Blu-ray is called a Blu-ray, because blue light is used for reading the information. Okay. So as you see, and this is the titanium sulfide laser. Here, let me see. Yes, here is a titanium sulfide, which is resonated. Here's a resonator, and then and the laser is coming out toward. I'm not sure about this from this figure, and so anyway, by this green light is the excitation of titanium sulfide, and the generated light is mostly red light. You could see in a crystal region somewhere like this. And finally, I would like to mention the coherence of the laser. No, finally, what? As I mentioned, laser has a property of the coherence. Right? Coherence I mentioned. And here's a diagram of the laser, the field intensity. Okay, so as it propagate in time, propagate in time, the waveform is gradually waveform propagate. But if the wavelength difference is included, looking at green and red, even for a minor, as it propagates, the difference is getting bigger and bigger, and finally it's getting opposite, right? This is called a coherence lens. If the light source has only the red type of the oscillation, even after propagating here, the light has interference ability. Right? So light can interfere each other to increase or decrease. However, if the light source includes the green type of light too, so as it propagates here, it's already lose the interference ability. So that's the coherent lens.